Hello and welcome to Monitoring.Sydney. This is a live stream brought to you by a group of volunteers from the Sydney monitoring community. And before we begin with our guests, let me go through a couple of intros. So, first of all, we have a very simple policy. This is a safe and welcoming space. Please be excellent to each other and treat each other well in the chat, Slack, and groups and other channels that this group represents. If you see any issues, please do contact organizers at organizers@monitoring.sydney. You can also drop us a line regarding any questions you have, or if you want to talk on our panel. With that, I want to also say that we're always looking for community speakers. So please don't be shy and drop us a line if you're interested in talking. So today, our special guest would be Pranavi, who is heading observability at Canva. And then we will have a monitoring panel where we'll be joined by Alex Hidalgo, who's a SRE at Noble 9 and author of the famous Implementing Servers Level Objectives book. Then we'll be joined as well by Ken Mugrage, who is a tech principal at ThoughtWorks. So with that, let me give a voice to Pranavi.
My screen now. So hi, I'm Pranavi. I work as an observability engineer at Canva. So I'm a new starter at Canva. It's been, I think, around 9 weeks now. So learning a lot, and it's been pretty awesome so far. So just before I joined Canva, I worked as the lead SRE engineer at Campaign Monitor. So for those who don't know about Campaign Monitor, they're a really cool email marketing company. So a lot of big companies like Rip Curl, Australia Red Cross, they all use Campaign Monitor to engage with their customers via emails. Like they send millions of emails every day. So what I'm going to talk about today is our journey to building observable systems at Campaign Monitor. So how did this journey begin? It was one fine day in December 2018. I got rudely awakened by a PagerDuty call at 2 a.m. 2 a.m. is always a perfect time for PagerDuty to start blaring. So I had recently joined the SRE team, and I was just, getting into the on-call experience and stuff. So I got paged. I woke up, and it was about a monitor. So it was about a monitor saying that RabbitMQ has too many messages. So yeah, I was like, cool, RabbitMQ has too many messages. I know what the problem is, but that was about it. I didn't know why. I didn't know which service was consuming it. I didn't know whether there was a problem with any downstream or too much load, like no idea. Because it was my first time, I had the team lead to shadow me. So we both were working out the problem together. So at that point, I was trying to see, I couldn't figure it out straight away. So I was trying to see how was the other person troubleshooting the problem. And a few things stood out. For example, the team lead kind of knew straight away which service was consuming from the RabbitMQ, and also knew what the dependent services were. And we were able to figure out that, downstream there was a SQL issue, and hence all this problem happened. So there was a lot of assumed knowledge in there. So the issue got resolved. We did like an incident response and stuff. And this gave me an opportunity to kind of reflect on what actually happened that day. There are few problems that I uncovered. The first thing is the tribal knowledge. There's so much information that the team lead knew that I did not. And Campaign Monitor had really strong engineers who've been there for several years, like for example, 6 to 7 years. So they've built so much knowledge over time that it's really hard for them to see what's missing. And there was another problem because the team lead was going to leave in a few months. So I was like this, how am I going to ever get so much knowledge transition? It's not possible. And Campaign Monitor is also growing, and it's a polyglot environment. So it started as a C# stack, and then they moved on to Go and Java. Forget a person, even for a team, like the SRE team, to have knowledge of what's being built, what's going out, it's really, really difficult. So the one main problem we had to solve is not rely on the tribal knowledge or engineers to kind of fix the problems, but to have observable systems. So what do I mean by an observable system is, for me, if I can understand the inner workings of a system, not because I wrote it, not because I know I made a code change, so I know how it works. None of that. If I understand the workings of a system from the external information that the system emits, then I would consider the system to be quite observable. For example, say when I woke up at 2 a.m. and I knew what the problem was, but if I was also able to identify why with the information from the system, then that would be a pretty good observable system. So how do you build this kind of system, right? You just can't hope to have an observable system. You really have to build it. So it's a very conscious decision when you build a system that you have to emit the right events. So we can have some other system to aggregate the data and to make sense of it. So with regarding to events, I've kind of categorized them into logs, metrics, and traces. I'm pretty sure everyone's familiar with logs and metrics. Traces, a lot of companies are getting into them at the moment, but they're like super useful. So when we first began this journey of let's improve the observability at Campaign Monitor, the first thing that we did was to look at logs, find out what were the gaps there, improve them. Then we moved on to metrics. And at that point, we didn't have traces. So we found the gap, and then we had to introduce tracing. So let me just go through each phase one by one. The first thing, like I mentioned, the logs. There were plenty of logs, like no issues with that at all. Like everybody loved logging stuff. Our system was always flooded with logs. But and then we had a really nice centralized logging system. So we used AWS Elasticsearch for all the logs, and we used Graylog to access it. The problem was searching for the logs. The problem was finding the right logs. So the first thing we wanted to solve is to have a really good structured logging system. So there are a few examples here, completely random examples. But as you can see, as a human, I can understand, I can read the log message, right? It says it's a timestamp, it's like a user ID or some form of an ID, and it gives me like a method name, etc. But as a machine, it doesn't really understand this line of log. It can't automatically parse. It can't automatically strip them out as fields. Especially with using a really powerful system like Elasticsearch, which can do amazing aggregations and everything, it'll make more sense if the log message is structured in a format like that, where we give specific fields and specific values, so we can actually search by a field. We can aggregate by the result. So it was really crucial to have structured logs throughout the system. So there were some systems that had it, that some systems didn't, but there was no consistency. So we went about having like a more consistent way, which kind of meant picking a library, for example, Serilog for C#, and rolling it out across microservices, across monolith, across all the services, and enable the developers to actually use this. And then, when you look at the log message, it's so much more useful. And especially when you are dealing with an unknown system, having all these fields show up in the searching system kind of tells you, oh, okay, this log message has a resource, so maybe I can search by it. But if it was just a plain string, you had no idea, what string you can search for in the logs and things like that. So the first thing that we improved was to have a really good structured logging across the system. And the next thing moving on was correlatable logs. Forget microservices, right? Even within a single service, a request travels through multiple classes and they all have their own log messages. especially if it's like a multi-threaded system. It's really hard to kind of see the journey that one request has throughout your system. So it's really important to add a context to every single log message. So you could go to a naive approach where you can pass this context through every single function, but that's not optimal. You can't do that. So what you could do is, a lot of the libraries support adding context to like something like, say, a thread context or MDC utils in case of Java. So when you add this context, say a request ID or a client ID, it is carried throughout the processing of the request, which means and every single log message will look for this contact information and will automatically add it to the logs. So this really helped us because we have a lot of batch processing happening and a lot of multi-threading happening, and it previously everyone relied on kind of using timestamps and stuff, but very soon once we had correlatable logs, it made a world of a difference to kind of go through one batch of messages and see what happened end to end. So with structured logging and enabling correlatable logs, there was a significant improvement with respect to the searchability of the logs. So once we knew kind of what to search for, it was so much easier to get the information. And in order to have some consistency, like I mentioned, because we had a polyglot environment, it was kind of important to pick the libraries and kind of stick to them. So if a C#, Serilog was really, really good, and for Go, Zerolog, and for Java, it was SL4J with log/logback encoders. We kind of had this consistency across the microservices and our monolith, so it kind of significantly improved searching logs. So once we were satisfied with our logs, so we moved on to metrics. So metrics are, again, events which are aggregatable. They're amazing to kind of give you a really good bird's eye view of the system. You can create dashboards with metrics. You can create alerts. They are great service level indicators. And we used Datadog for all our metrics. Like Datadog collected all our metrics, and we were able to create monitors and alerts, sending them to PagerDuty. All of our engineers really used metrics quite well, and it was used extensively. What was missing was, again, key metrics. So we couldn't identify, or not all the services had all the key metrics. Say, for example, every single service has inputs and outputs. For example, it could be reading from an SQS message, writing to a SQL server. So for each of this input and output, it's really crucial to have these key metrics, which are traffic, what is the load, latency, how long is it taking to process the request, what are the total number of errors, and if it's another service that you're reading from, what is the saturation of resources on that specific service. Having these key metrics for every input and output would really help to kind of narrow down where the problem is. Because if this is not consistent, like say if some inputs have these key metrics and some outputs don't, it's really hard to diagnose in a microservice kind of an environment where the problem is. Is it the input, or is it the output, or is it the service itself? Like there's so many questions that's very hard to be answered if we didn't have all these key metrics. So it was really important to kind of ensure that if you had an input and an output, to have all these key metrics configured. And another important thing was every service kind of had this way of naming their metrics. They had the service name in the beginning, followed by the metric name, which was HTTP requests total. This worked as long as just the team needed to look at the metrics. But imagine as an SRE team, when we had to look at the metrics across the board, we wouldn't know that we had to look for payment service or auth service and things like that. So what would be really ideal is to have a standard metric name, which is HTTP request or total, and then tag them by the service. So we can have even one dashboard that covers the HTTP request across all the services. So this was also quite an important change to give the SRE team a much, much better visibility of what's happening across the board. So we were at a good stage, right? We kind of improved the logs a bit. We kind of improved the metrics a bit. So we were like, yeah, I think we are in a good spot now. But still, there was a gap. There was a gap in observability. So with respect to logs, like I mentioned, you always need to know what log message to look for. So again, this was another interesting incident. So I got paged, again, middle of the night. So I knew it was, there was a service. It was struggling to keep up with the load from a Couchbase server or something. So I knew I had to scale it up. I scaled it up, resolve the issue for the night, but I didn't know why. So next day morning, I go to the team and then I ask them, why was this extra load? So what was actually happening? The team immediately looked at the logs and said, oh, it was because there was a key sync or something happening. I was like, how? I was looking at the logs for a couple of hours last night, but I couldn't find it. It's because the team knew exactly what log message to look for. They looked for a message called key synced. I wouldn't know what log message to look for. And that's when it was really, really evident that unless you knew what to look for, logs weren't super helpful. And logs are great for forensics, right? Like what I did, I solved the issue. The next day, the team was able to look at the logs and find out what the problem was. So it's a great forensic measure, but it doesn't give you a live picture of what's happening with your systems. So that's how much logs could cut for you. And then even with metrics, right? Like it would give you that bird's eye view, it will give you a holistic understanding, how healthy your systems are. All that's great, but it doesn't give you the depth that you need. Like cardinality comes with a huge price tag. For anyone who's used Datadog, you would know that anytime you add extra custom metrics, you are charged quite heavily. So we had to really restrict what tags that we had to add on all our metrics. So with logs and metrics, we kind of knew that this is how far we could go. There was something missing beyond this. And like I mentioned, with logs and metrics, we got to a good state where if we knew that there was a problem with the service, we could, try to find out, is it this service's fault or no? Let's try this service. Or this service looks healthy. Okay, let's try the downstream. Some teams had good dashboards, so you could kind of see the inputs and the outputs. And for those that didn't, you kind of had to have some knowledge. You needed to know what the upstream and the downstream was to kind of find the issue. So that's when we introduced distributed tracing to campaign monitor. So we kind of, how it started was we came across this blog from Datadog about their new APM feature. So we thought, let's do this. Let's just enable, because we already had Datadog agents in all our instances. So we thought, let's just enable APM. Let's just install their default library, Datadog library. It came with some basic instrumentation for HTTP requests and SQL. So we thought, let's just do that and see what it looks like, because we want to know if it's worth the investment. Just with that, basic level of HTTP requests being traced and SQL being traced, we got an enormous amount of insight into what our system was actually doing. So the best way for me to kind of explain the benefit is I thought I'll steal some pictures of Datadog's blogs. So basically, again, traces are also events, and say span and trace, they're all events. And span kind of represents like a single unit of work. And one span relates to another, it can have a parent-child relationship. So you can kind of see the flow of a request, like which request called into another request, it called into another service. So you'll be able to add all of this metadata into a span. And trace is like gives you end-to-end look into a request. It's also a span which doesn't have like a pattern because it's like the root span, like let's say the topmost span. And you can actually see the picture here. It kind of gives you like what happened when we got like a GET request on the user's API. So basically, it kind of made a call to Redis. It made a call to SQL Server, but in between, it also had some errors here. And you can also have the services. So previously, it was really so many incidents, right? We kind of figured out by using traces. Things like we would see 3,000 SQL Server calls here, even though they would take only a millisecond. So you couldn't really spot it in a metric or something because it was super fast. And we were like, why is this making 3,000 calls? And we would figure out that there was a for loop and there was a SQL Server within the for loop, a SQL Server call, and hence it was bashing the SQL Server. Because we had massive ones, it didn't really cause a problem, but there's so much insight that we wouldn't have known previously was all transparent once we introduced tracing. So once we were really happy with the results, we went ahead and heavily invested in tracing. So with tracing, right, like I mentioned, you can also have, if there was an issue with the span, and if you had instrumented to kind of add this exception on the span, you would just be able to click the span and see what the exception was. You wouldn't have to go search for it in Greylog. Like it was apparent and it was right there. And the next thing is all these key metrics that I was talking about comes by default. Again, because span is just an event, Datadog will aggregate it for you. And for every service, it will give you what was the total requests, what's the latency, the total number of errors, and total time spent per service. That was really important. So you can see as a service, am I spending maximum time on Redis or am I spending a lot of time on SQL? So you can actually get this per service breakdown, all just by having spans and traces. So once we had this, we were even able to remove a whole bunch of duplicate metrics because we already had total requests and errors and latencies. So we can then focus on more important or more relevant metrics per service. So once we added service, you can also get a span summary. So you would know even to the detail of which SQL query was the one that took the most amount of time, and how many of these SQL queries that we actually executed. So you can have all this information by instrumenting your application to have spans and traces. And another really cool feature was obviously you have to have a service map. So it's like really nice way to see what the requests were, what the services were, and it was really nice way to kind of see another really nice bird's eye picture of what was happening. And I actually kind of sound like I'm an ambassador for Datadog. Full disclosure, I'm not working for Datadog. Datadog is not paying me to do this. But Datadog's APM feature kind of helped campaign monitors significantly with this whole observability journey. There are so many APM products out there, but this kind of fit our gap, and it really helped us with our journey. So all this kind of information that I gave you about how awesome tracing is, it's not possible without instrumentation. It needs heavy instrumentation. So once we were kind of happy with the base level information, and then we decided to go to every single service of ours and add these spans and traces. I just have this really small snippet of code. What it means to add a span is, say, for example, if sort orders is a function that I want to track. So I would just literally create like a span around it. So this is a C# code. Using is like, once this function is over, it would automatically close the span. So these are the tiny spans that you see. So say this whole parent-child relationship that I was talking to you about. So you can have a parent span, and then you can have like multiple child spans. So basically, the sort order span that you see here will kind of consist of all these other child spans going forward, and it'll give you a really nice flame graph that I showed you before. So these, again, CM being a polyglot environment, there were quite a few services. We used Kafka, SQL, Redis, Couchbase, gRPC, SQS, RabbitMQ, all of these awesome services. So it was really important that we, even across all the languages, so it was really important to kind of have a very similar, and a consistent structure for tracing across all these services. And when, for example, for SQS, if I wanted to make sure that the producer and the consumer of an SQS message were being able to link in a trace. So I would have to pass the trace ID and the span ID in the SQS metadata, and then the consumer will consume it and use that trace ID and span ID as the parent. This goes for any of the things like RabbitMQ or gRPC. So we kind of had to come up with ways of how we are going to carry forward, this trace context across distributed services. It was a couple of months of work, but it was totally worth it. Like at the end of it, some of our architectures, for example, it would use a Go service and a Java service and a C# service with, in between a couple of Kafka topics and stuff. So to be able to see end to end a service like that was pretty amazing, and it wasn't possible. And the amazing fact is, if someone introduced another service, I didn't have to know about it. Like if I looked at the trace, I would be able to see all the services that were involved in solving or giving a solution for that specific request. So it was like a significant game changer, having to see everything end to end. So we at this point, right, we kind of had best practices for a lot of things. We had best practices for logs, we had metrics, and we had tracing and everything. But just one team couldn't do everything end to end. So we really needed the developers to kind of help us with this journey as well. So one of the most important things to do was a production readiness documentation. And the reason for this is, for example, when you have a service and when you want the SRE team to take over the production on-call for this service, we needed the teams to fill this documentation. And it had all the checkpoints. Do you have structured logging? So does your service use correlations? Do you have the right key metrics? Are you using the right libraries with tracing in them? So this was really like one thing that tied up the entire the entire journey, because at this point we were quite confident with all the improvements and we wanted every team to follow it, and we also wanted a checkpoint to make sure that every service kind of had it. So finally, with this kind of rolling out, so every team was able to see what was missing in their service and kind of add more metrics or tweak their logging and things like that. So this kind of sealed the deal for the entire journey. Personally, I'm always really interested in the cost, because some of the most sophisticated distributed tracing libraries are very, very expensive. So we kind of had to always keep cost in mind. And whenever anyone talks to me about their observability system, I always ask them, oh, how much does it cost? Because it was really, really interesting to see how much people are willing to spend on the observability platforms. For Campaign Monitor, we spent around $160,000 USD on Datadog for metrics and traces. And for our log pipeline, we used Graylog and Elasticsearch. So that was around 54,000 USD. So it was pretty good. And we also we had to justify, like, do you think we're getting the benefit by spending so much? But I can definitely say that at the end of this, the on-call experience was just so much better. So waking up at 2 a.m. was not that scary anymore, because you didn't have to also go hunt down why, because the why was always obvious. You just had to go now and fix the issue. So the overall journey, which took a couple of months, really paid off. And that's pretty much what I had to talk about observability and the journey. So thank you. It's so hard, the remote.
One second. Pranavi, thank you very, very much for your presentation. It was fantastic. And now we are preparing for our panel, so don't go anywhere. Just give us a little bit of time to set up the video from everyone properly, and we should be ready to go. So Just 1 second. Let me. Pranavi asked me to just give her 1 second for a plug. Let me switch the screen. You have voice?
Oh, okay, awesome. There was one thing. So even though I spoke about Campaign Monitor a lot, it's an awesome company, but now I work with Canva, which is amazing as well. And then we are hiring. So if anyone's keen to work for Canva, please do apply. Be awesome to work with some cool engineers. Thank you.
All right. So I'll let our panel speakers set up, and in the meantime, we will dissolve for a very short break. Like, give us like 3 minutes or so. Hello, and now we're back with our panel today here. So let me again introduce Pranavi, who works in observability at Canva. Let me introduce Ken, who is tech principal at Floodworks, and let me one second. Let me just fix something on the map. Here we go. So Sorry, folks, some technical issues. Let me make sure that the channel is working. Okay, and let me introduce Alex Hidalgo, who is currently an engineer at Node 9, if I remember correctly, and of course, like the famous author of Defining Service Level Objectives book. So first, with that, I wanted to start with just can you folks introduce yourself? Like Pranavi, you already did that, but I wanted like Ken and Alex to have a chance to do so as well. So
sure. Any particular order?
Yeah, Ken, you can go.
Okay. Well, as was said, I am what we call a tech principal at ThoughtWorks, which of course means nothing. But I currently work for the office of the CTO on tech strategy and stuff. I get passionate about this topic because for a few years I ran some of our products, including GoCD, our continuous delivery server. And I see this as an important part of being able to deliver software and DevOps and that whole thing.
Awesome. And my name is Alex Hidalgo. I am the principal site reliability engineer at Noble 9. Which is a company focused entirely on SLOs. As was mentioned, I wrote the book on SLOs, implementing SLOs. You can go find that anywhere that books are sold. I think it's even natively available in Australia now and most of Southeast Asia and stuff like that. And yeah, I've been an SRE for a very long time. I've been doing this for more than a decade now. And I'm very passionate about figuring out the right ways to keep services reliable, so that the humans that rely on those services can hopefully be happier as well.
Fantastic. So I wanted to ask you all, which so-called definition of observability do you subscribe to? So what is like observability for you?
Do you want to call on people?
I guess Pranavi, you can start.
I mean, the talk that I did was purely on observability, and then I mentioned a few times to be actually able to understand what's happening inside the system. You know, especially if you're an SRE team, there's a chance that you would not have written it. You would not have even known it existed, right? So to be able to understand how it works, but from its events it generates, that means the system is observable.
Ken, and what are your thoughts on the definition?
Yeah, really pretty close. I don't subscribe to any, given written definition necessarily, but it is to be able to actually see what's going on. And, it's cliche. We were talking about it earlier, and I think you said it in your slides too, Pranav. It's the unknown unknowns. I can log the things I know are going to happen, but in today's world of distributed systems where I don't even control half the services, there's some, Azure API for AI or whatever it is. There's just no way to know the things that might go wrong.
And Ken? Oh, Alex?
Or Alex. Yeah, so in my opinion, it's actually pretty close to how the term was originally posited. It was come up with Rudolf Kalman back in 1971. And, the idea was as a subset of control theory, this, observability is being able to infer what is happening inside of a system from its external outputs. And so for computer services, that very well may be something like structured logging or time series data or traces or things like that. But I think it's important to not conflate monitoring or metrics with observability. Monitoring and metrics are artifacts. Observability is a state a system has. Can you find out what's going on inside of a system is observability. The artifacts that allow you to do that's monitoring. That is telemetry.
So you mentioned that the term is quite old. So did it come in this case from more industrial type of systems, or is it what did it come originally from like a more computer science background, or just mathematical systems? Do you know by any chance?
Yeah, it was much more of a mathematical system than anything else when it was first being developed. The concepts stemmed out of control theory, which is a part of systems theory. All of which is, generally speaking, and especially by Kalman, who coined the term, in a paper. At the time, it was a mathematical curiosity, thinking about how we can talk about these things. It very soon, of course, did apply to computers, because computers and mathematics departments in the 70s were very closely tied. So very quickly, it did come to also mean how can we think about computer systems, but at its absolute root, at that very first paper, it was kind of purely theoretical.
Understood. So while we're on the topic, I know that Alex, for you this would probably be of course you have done so, but I'm more interested in like Ken's and like Pranavi's opinion on this. We had a question like previously on whether people have have you implemented SLOs where you work, and have you and like how do you think this is connected to observability, and is it connected to observability at all, or this is like more of a separate topic of like reliability?
I'll go. At Campaign Monitor, so we had SLOs, especially because we are sending millions of emails. So we had to make sure we are sending an emails at an expected rate. So if that dropped, then we knew that we were not satisfying the requirements of a system. So we had an SLO for that, and we had some indicators for that as well. So for me, SLOs are really important, because if you kind of can't measure, then how can you improve? So observability and the measurement is really important to kind of find out how reliable your system is. So if I didn't have observability, then there's no point in having an SLO, because I won't have an indicator. So you need the indicators, and then you need to have the SLOs so that you can then measure how well your system is doing. And it also gives you like a safety net. So if you're introducing a new feature, how do you know if it's doing better? Like, how do you know that the engineers can safely say, yes, I didn't break anything because the SLO was still guaranteed, right? So it definitely goes hand in hand, in my opinion.
Yeah, agree completely. I mean, we're primarily a software consulting and delivery company, so they're not our systems, they're our client systems. So to the first part of your question, do they use them? It depends on the client. We certainly encourage them to. Not everybody does. But, especially if we look at like federal health departments, I don't want to name any names, and those kinds of things. And, they're looking at chat bots that to go through symptoms to say, should you see a doctor? Those things have really serious implications if they're not responsive, if they're not up, and they're not that kind of thing. So you have to have the measurements there, and you also have to, if you can, see it coming, if you will. You can't wait till it crashes over, because then it's on the nightly news, and we don't want that. So I think they're really important. I wish more people use them. I got to be honest, a lot of our clients don't, but I think they're important.
So with that, since Alex, you have so much experience in implementing SLOs, I wanted to ask, so how does one have a conversation around SLOs and reliability at a place they work? Like, for example, they want to implement SLOs. Like, how do they talk to their team, or like how do they talk to stakeholders about it?
Well, that's a very complicated question. There is a lot to be said about that. I think your question is answered, for example, in the book in 3 different chapters for a total of about 16,000 words. Like but the quick version is something along the lines of, you can generally easily persuade someone that reliability is the most important feature of any service. That does require the correct definition of reliability, which is it doing what its users need it to do? Right? Is a system designed, or is a system performing the duties it was designed to do? That's what reliability is meant. Again, to get all historical, all the way back to the term reliability engineering is from U.S. Army document in 1946, I believe. Right, like this again. It's not anything new, and when we're talking about reliability for computer services, it's no different. Is this system doing what it's supposed to be doing? We're not talking about is it up. We're not talking about is it available. We're not talking about are there no errors in your logs. That's not what we mean. Reliability means is it doing what users need it to do? And then once you get that across, the next step is generally telling people, okay, cool. Now that you agree with that, the second thing you're going to just have to agree is that nothing's ever 100%. Everything fails at some point. And people get this. People understand this. You can easily give them a million examples. Ask them how many times they've been at a restaurant and the wrong dish came out. And then ask them how often they actually stormed out of that restaurant versus just sending it back, for example, or having something slightly fixed. Or, one of the easiest examples you can use with people is talk about a media streaming service, Netflix, Hulu. I don't know if you have anything specific, like down south, but it's sometimes it just doesn't work well. Some nights your stream is kind of choppy. Who knows if that's even Netflix's fault or Hulu's fault or Disney Plus's fault, right? It might be your internet connection. It could be some intermediary. But the point is, everyone intuitively, when you tell them a story like that, understands, yeah, you're right. Sometimes stuff doesn't go right. And I'm actually okay with that. Humans are okay with failure because everything fails sometimes. So those are the two lessons that I think you need to instill in people. If they're able to accept 100% is impossible, so let's aim for a better target. And if they're able to accept reliability, aka doing what a service is supposed to do is its most important feature, once you can sell people on those two things, then you can say, that's all SLOs are. And I think that's the best way to start that conversation. It can get much more complicated, of course. There's much more to be said about it. But I think if you are starting from square one and you have no idea what to say, go convince someone of those two things, because those are two things it's pretty easy to convince someone of.
Do you mind if I add something to that?
Of course.
I think whenever you're trying to drive any change, when you're trying to get people to adopt things, if you're trying to get people to spend money on tools, et cetera, facts are great, but nobody makes decisions based on facts. If you think about the last major purchase you did, there was some emotion in there. Mm-hmm. And so when you're presenting these ideas, it has to be about, the risk or the reward or those types of things. It's a social thing. It's the people. You have to go through and say, this is why your life is going to be better if we do these things. And then you're going to go to the next person, and it's probably a different answer. This is why your life is going to be better if we do these things. Numbers are great, but they don't get it done most of the time.
So it's almost like you.
Yeah, I totally.
Oh, sorry.
Oh, I was just going to really quickly add. I totally agree. That's it's narratives. Humans are storytellers. As engineers, we often like to think that we gather a bunch of data and metrics, and we put this in a report or a spreadsheet, and we put it in front of someone that's going to mean something, and it rarely, rarely, rarely does. People like stories. They like narratives. That's why I like the Netflix Hulu example, for example. But yeah, that's a great point. You need to weave those narratives. You need to weave the human elements into every single part of it.
So it's almost like you don't sell a product, you sell more of a narrative, and you sell more of an idea of how it's going to perform.
Yeah.
So
in my mind, I actually did a talk that I said you can't buy DevOps, but you may have to sell it. And that's what it basically meant, is it's not a product you can buy, but you may have to go through your organization and convince people of the need to adopt different behaviors.
Oh, I think that's actually a great quote. So one thing, while we're on the subject, I wanted to use this as a slight segue. So Alex, in your book, you talk about reliability being a conversation, first and foremost. And so, but are there some conversations around reliability that you think are not very productive, and how, and for example, how those can be improved?
Yeah, a few things immediately pop to mind. For me, I think we have a bit of a delay over several thousand miles.
Yeah, now I think it's going better. Apologies for that. Yeah, Australian internet is already not amazing, but when we add a bunch of delay to it, it is a little bit hard. You should have. Yeah, you should have a channel now. So can you try saying something?
Sure.
Yeah, beautiful.
Yeah, definitely. So there are a few general problems that people run into when they don't think about reliability in the right way, especially as they pertain to service level objectives. And that's just one, they often conflate the concept of reliability with something like availability or uptime or something like that. As I just kind of talked about, one of the first steps is you need to make sure people understand what the word reliability actually means. What does it mean for your computer service to be reliable? And part of that is exactly what was touched on at the very beginning of this panel, which is the concept of observability. Your service level indicators, the things that tell you, is my service being reliable or not? Sure, when you're getting started, maybe this can just be a time series metric that tells you what your error rate is or what your latency looks like or something like that. But for comprehensive service level indicators, you really need something that travels the whole user journey. When you are trying to figure out whether or not your website is reliable, it's not just, is it up and does a page render? It's, if I try to reset my password, am I able to? And if that's the case, you need to be measuring not only does the page render and does it render in time, but can the user click the reset password button? And if they do, is an email actually sent? And then is that email received? And then if the user clicks on the reset link or the acknowledgement link inside of that email, does that actually bring them back to the password reset page? And then when they type in their new password, does that one stick? Does it persist? Is it consistent over time? Those are a lot of things to measure. And very few people get all the way there. And I'm not trying to imply you're doing SLOs wrong if you're not all the way there. I 100% don't mean that. What I mean is that has to be your goal. How close can we get right now? This is a perpetually iterative process. When you mention that I say reliability is a conversation, a different way to put it is reliability is iterative. It is ongoing for all time. It's not a thing you do. It's not, cool, we're reliable now, we can go do something else, right? Like that's not how it works. And just like the example I just gave you, that's very complicated. Are you ever going to get to the point where you can perfectly measure that entire human user journey? Mm-hmm. Probably not. Do you even have to? Probably not. But the more reliable you want to be, the closer you have to get to being able to holistically kind of measure that kind of thing.
So is there a point where you but is there still a point where you stop adding like more monitoring or like more like additional like hedges on your observability?
Yes. Once you're good enough for your users. That's all, we're kind of delving pretty deep into just SLOs at this point, but I like to tell people that the only important part of a service level objective based approach is actually just the service level indicators. The only important part is, are you measuring what your users care about? Now, SLOs, your SLO targets and your error budgets, how have you performed over time windows, all that really is it's some pre-done math on top of your SLI that helps you think about how reliable you've been. It's all about thinking about your user. So yeah, if your measurement is good enough, then it's good enough and you can go do something else. SLOs are all about not being perfect, right? At their very base, they acknowledge things are never going to be 100%. That means your measurements aren't ever going to be 100% either. And that's fine as long as they're good enough. An example I always like to give is my last company, Squarespace. One of the services I ran was a massive Elk stack, like an Elasticsearch, Logstash, Kafka, and it was the busiest service at Squarespace because every other service at Squarespace wrote to it every time they got any kind of request. It was massive. It was huge. And it was difficult to wrangle. And we realized we needed SLOs. That was the very first defined SLO at Squarespace. And a perfect or a very good SLI for something like this would be, can we insert a log into the Kafka queue, have it be processed through various filters. Does it show up in Elasticsearch as indexed? And then can we access it via Kibana? Right? That would be the whole user journey. That's how users, other engineers at Squarespace would actually use this service. But we got close enough when we realized that if we took the total number of messages in the Kafka queue and divided it by the rate at which Logstash was indexing logs per second, we got a pretty close mathematical approximation to the average end-to-end latency. This is a perfect measurement? No. Did it take into consideration like data integrity as opposed to just latency? No. But did it turn out to be good enough for our users? Absolutely. 100%. So there's no reason to spend more time on it. So we moved on and we tried to fix other things. So it's fun and it's good to talk about the complicated because you want to get people in the right mindset. You want people to think about what do the users actually need from us. That doesn't mean you actually have to measure those things. Just get as close as you have to.
Yeah, and if I could, Pranavi actually touched on this in her talk. There's also a different level based on what you're actually looking at. So your risk, that sort of thing, as to when I'm done. So, I mean, if you, inside your organization, have a service that serves cat gifts to Slack, then you have another service where people, input their hours so they get paid. Those have a different level of need as far as their reliability and all of these things. So when you're done might vary inside the same organization and team. Well, there is no done, but when you're
Right.
And Pranavi, do you have any thoughts on this?
Yeah, absolutely, I agree with that. Like when what I mentioned in the talk, where we did go as much as we needed to go, and then we said, "Good, that's good enough." Like we now know enough information to fix the problems that we can fix. And do the customers, even with SLOs, right? Like you can say, I need 100% of my requests to have 1 second latency, but that's not needed. Like just thinking about the 95th, this is good enough because there's so many other problems that we can actually focus on. So it's really good to kind of agree to a specific point and then move on to the next problem. So yes.
One thing I wanted to also ask all of you, and that may be a slightly more like a slightly cheeky question, I would say, is that recently there has been like a large movement about like testing in prod. So what are your thoughts on the topic?
I have strong feelings. Jordan was actually wearing a shirt that says I test in prod.
Yeah.
Unless you never release anything, everybody here tests in prod whether you want to or not. Because I mean, in today's world of massively distributed systems, and we're even moving from calling them platforms to ecosystems where, people are competing, just like in a biological ecosystem for I'm going to use this credit card processor, but now for, it's going to cost me 5% less to change. So I change. Yeah, it's a different service from a different vendor and what have you. There's no way that you can simulate a real user in your testing, nor should you try, is my opinion.
I agree with Ken, absolutely. So it's really hard to get the same experience. So if you have the right metrics in place, the right feature flags, that'll help you tune it and help you test, say, 10% of your users. And if you have a really good safe way to roll it back, then there's definitely no issue testing in prod. It just needs a mature system though. Like I wouldn't say everybody should test in prod, but you should kind of know that is your system mature enough? Like can you roll it back with a millisecond differences? Then I think you should test in prod. Yeah.
Yeah, and that's why I love that you mentioned things like feature toggles that are so easy to change. Because the other thing that you get to test or observe, or however you want to put it, is the business efficacy of your change. It's not just does it work and someone can change their password. Obviously, user journeys, but did sales go up or down? You can test all those things that you could never simulate that, but you can see like, is this doing what I needed it to do for my business? And if not, that's a good reason to roll back. Probably a better reason to roll back.
Yeah, I mean, you will just simply never have a dev environment, a QA environment, a staging environment, whatever you want to call it, that actually looks like a production environment. Not only is it too expensive, You'll never have the same scale. But let's say you actually do that. Let's say you actually have a full mirror of what your production environment looks like in terms of how many servers or services or VMs or pods, whatever you have. So now you're spending double the resources. And then you're even teeing all your traffic. You're literally doubling all inbound traffic and sending it to everything. And you're saying, cool, now I have two environments that are identical. But they're not, because only one's actually responding. Unless they're both responding. And if they're both responding, then they're both prod. Like it's literally a mathematical equivalence to say you can possibly have something that actually resembles your production environment. So I don't believe in dev environments. I don't believe in staging environments. I'm not saying you shouldn't have them, because getting beyond them is very difficult. So I'm at my current company, we do, right? Like I'm absolutely not saying you're doing it wrong, but the ideal goal is to get very good A/B testing, get feature flags, get a good canarying setup, get a good rollback setup, have automatic rollbacks. Something awesome that we did at Google, for example, was there was a service that would watch your service, and if you pushed out a new version and any attribute of it changed in enough of a factor, it would just roll it back and then tell you, hey, sorry, that binary you just pushed, memory usage went up by X amount, or RPC request error rate went up or even down. Anything that changed too much, it would then tell you. And sometimes this was intended. You say, yes, that's fine, cool. Thank you, system watching me. It's fine, and we're going to deploy anyway. But like you can build very sophisticated systems that allow you to more carefully introduce changes into production, because that's the only way you're going to get real testing feedback.
Since you mentioned canarying, when I personally last observed the market, there was not a lot of turnkey solutions for it. So for example, like Kayenta is quite like, it's just essentially like a verdict service, which you still need like to spend quite a bit of time like integrating into your environment, unless you're using Spinnaker, but that's like a whole like other beast. There are some experimental controllers for like Kubernetes that do some of those things, but they're pretty rudimentary. Do you folks like have like, maybe you have had an experience with like canarying in your setups, and is it always something that needs to be like written at home from scratch type of thing?
Yeah, I don't know. I have to admit, I don't know. It's exactly the ones. I mean, there's the canary side of actually doing deployment and making sure that works, and et cetera. But then the testing and prod side, to me, I like it to see it done with things like feature flags and stuff, where it's not a typical what you think of as canary, because it gives you a lot more control over saying it's not just a percentage of traffic or a percentage of pods that I'm going to deploy this to, but I'm only going to deploy it to people that are coming from this network. So you're going to use it for employees first, or I'm going to test this first for people that are, a certain type of customer or what have you. Microsoft does this a lot. I think they call it blast radius or something like that. Those are hard to do in a true, what I think of as anyway, from a continuous delivery perspective, as a canary, and easier to do with things like feature flags. And then a lot of those are roll your own, but there's also SaaS providers for that.
I don't have a lot of experience with Canary. We just built a really, really small version where someone can just test out their branch, but it was a manual decision. Like you had to choose. So you knew that you were doing a Canary, so you were conscious of what was happening. And mainly because it's hard, and I don't think the SaaS products would fit everybody's needs. It's better that you could, because your indicators, right? Like your service is better, what matters. Because sometimes, I don't know, when it's sending a campaign, a latency might not matter, but delivery of the email really matters. So for things like that, I don't think it's really possible to use SaaS products. So we had to build something in-house. And I think Canva also does canaries, but it was built in-house as well.
Some of this you can do pretty easily out of the box. However, you may not get to a super sophisticated setup. But a good example is what I did at Squarespace is I built just basically a little template you could use for your Kubernetes deploys, which would basically say, okay, you normally have 60 pods running, but what happens is upon PR open, one of those 60 in prod takes your new PR, and the other 59 remain the same. And the change is not deployed to the other 59 until you actually merge. It's minor, it's not super sophisticated canarying, but it is a way you can, without having to write a brand new service, without having to, implement a complicated open source solution or this or that. You can still do some basic canarying, which is really just putting a new change into production, right? Putting a new change out there. That's all canarying really is. You can do a very basic version of it just on your own, right? Just take X% of your resources. And granted, this means you have to have a certain amount of resources, right? This isn't as smart if you only have 5 total pods running in production or 5 total VMs. Of course, that makes it a lot more dangerous. But if you're running at the right scale, it's not too difficult. You can, write a little scripting just to say, hey, make one of my 50, one of my 60, or one of my 40 even. Just have it run this new code. You may have to watch it manually. You may have to build some dashboards. Again, it may not be super sophisticated, but without building extra tooling or bringing extra tooling into your environment, you can still use the concepts of how to canary.
Absolutely. That's pretty much what we did. We were like, we need to test something in production, just this branch, but we didn't want to invest so much. So yeah.
But so in this case, what does production excellence mean to you folks then? So because we've talked about a lot of different things. We talked about that you need to have a monitoring, you need to have a good culture aspect, you need to have canarying, you need to have better insight into your systems. But if we I know there's that Dickerson pyramid of reliability, but overall, what do people feel what are the priorities within your internal kind of stack? What is the what is absolutely foundational and what can be worked on as your systems improve?
I'll throw the cliche out there. Happy users. I mean, at the end of the day, that's what really matters, right? Are you providing the service that people are expecting you to provide, that they're either paying you for, or it's an internal customer, or whatever it is? It's what did Chef Software used to say? Everything's to delight, or something like that. It's impossible to measure, frankly. But I don't care about response time. I don't care how fast I continuous delivery world. I don't care how fast your pipeline is. I don't care, I care if you can make the customer happy and get what they need.
Yeah, I think Ken is almost all the way there. I would just take his point and extend it. It's not just about happier users. It's about all the humans involved happy.
Yeah.
Because I don't care if the users are delighted if the engineers working on it who are on call for it are unhappy, or if the product teams are unhappy, or if the business aspect of your business is unhappy and you're not making enough money to stay solvent. So I think it's exactly what Ken just said. I would just expand it to all humans. And I don't care about the rest. I don't care about the machines. I don't care about the code. I don't care about the computers. I want people to be happy. I happen to work in an industry where that involves trying to make sure that software is happy and trying to ensure that services and computers are running well. But I don't actually care about that. Not really. I want people to be happy. That's really what I'm worried about, and that's what I think reliability really means. Are things doing what they're supposed to be doing for the humans they're supposed to be doing them for? We don't build computer systems for any reason beyond humans.
So, since you've touched on on people being, especially engineers that are working on something being happy, it is usually easy to say whether am I happy with something, but it's much harder to first judge whether the engineers kind of in your organization are happy. And the second is that I noticed it's sometimes harder to understand what and it's a very kind of contentious topic on what actually makes engineers happy. So I was wondering, what do you folks think in regards what what leads to engineering happiness? Is it just like, reliable and observable systems, or are there additional components to that?
I'd love to hear from Pranavi first here.
So, so having worked in the SRE team, right? Like we go on call for all the systems. I would definitely think that waking up at 2 a.m. is not so bad, but waking up at 2 a.m. and not knowing what's happening is really bad. So it's really important as an engineer, if you have the means and the tools to solve your issues, that's really important. So and then to have the support of everybody to kind of get together and fix the issue and make sure it doesn't happen again. So having a really good process of incident management and incident reports. And all of those will actually combine together so that everyone feels like a team. So, not just the person who's going on call, right? Like everybody comes together and joins a force and says, what can we do to make things better? What can we do that I don't wake up for the same thing the next day again? So that would mean like a happy on-call team.
Yeah, I think a big part of it too is this concept of psychological safety in a team is, the ability to experiment and try things and see if they work, and if they don't work, that's okay. That you learned and so forth. So it's really easy. It's a lot easier to say how to make people mad than it is to make them happy, frankly. But things like lack of control, like paging somebody at 2 a.m. that didn't write the thing, that doesn't know how to fix it, they don't have any control, that will lead to clinical burnout really quickly. So it's really, they're soft skills, but it's to me it is about not burning people out, which means they have control, means they have input. Actually, there's a whole bunch of, if you later I'll give references you can send out to folks if you want to. I have a fairly hot button about burning people out, but it's really about letting people have control of their own thing and rewarding them for doing things, and not saying you can't fail.
Yeah, and I would add on to that, kind of building off the concept of psychological safety that has to extend beyond just the socio-technical aspects of it, right? It's not just directly how this relates to work, but it's how your work relates to the real world. Are you building a thing that you are okay with building? Are the politics of the company that you're working for things that are acceptable to you? Is the product you're building one that you think is at least neutral, if not positive? And on top of that, there's just the concept of allowing people to not just psychological safety around the operational aspects, but do people feel safe to be who they are? Are they welcome to your team? Are they welcome to your organization? Can they say things like just earlier today? I started a new job only 6 weeks ago. I'm still pretty new. And you know what? Halfway through the afternoon, I was like, look, I live in the US. Shit's weird here right now, right? We got very, very important election on Tuesday. I mean, I think most of the world knows that. I'm not feeling it right now. And I'm done early today because I don't feel like I can concentrate. And I felt comfortable saying that because I've been doing this for a very long time and I'm very senior. And one of the reasons I did it in the first place is because I wanted to vocally say it so that other people who may not feel as comfortable, who may be more junior, see someone else saying that and see, wait, I can feel that way too. I'm also allowed to say something like, I don't feel comfortable right now. I don't feel safe right now. I feel burnt out right now. People need to be able to do that. It's not just in relation to the product, although, of course, it's very important. It's not like I'm disagreeing with anything said. I want to extend it that it's the human to human stuff. It's the human to society stuff. It's the human to what is currently going into the world stuff that is just as important.
Thank you for that. I think that is very useful for our viewers, especially because it's such a hard topic. So I wanted to wrap up the panel with like one last question from our Slack chat. Do any of you folks have any advice on kind of meta observability. So like who watches the watchman of like your systems. So, for example, like if you have like a tracing system, like or that you use to like, or like you have a monitoring system, like what actually like monitors the monitoring system that it performs as it is expected.
So, I was on Prodmon at Google, and then a brief stint on CRE, and then I joined Squarespace and joined the observability team at Squarespace. I've been thinking about meta monitoring for 5-6 years straight in a way. I think one of the best things you can do there is twofold. One, watch yourself with yourself, right? You may need to have a separate instance of whatever your monitoring is, whatever your alerting pipeline is, but whatever it is, make sure it fails open. If any fault is detected, you default to send the alert instead of inhibit the alert. Over paging, I know we're just talking about not burning people out, but over paging is better than under paging. Just like over communication, while sometimes annoying, people often tell me I over communicate. That's still better than under communicating. It's better to tell someone the same thing twice than it is to not tell them at all. So watch yourself with your own product, because it gives you a better idea of your product is working, and build your failure modes so that they fail in an open manner, so that the default is people know about this.
Ken, do you have like any thoughts on the matter?
To be honest with you, going back to psychological safety, no. I don't have a solution or an answer to that. I loved Alex's, but no, I've never actually run against that.
No worries. In this case, I wanted to also, before we finish the stream, I wanted to give everyone an opportunity to, like, if you have anything to say to our viewers, or if you want to plug something, like for example, if you're speaking at an event soon, or like Alex, we do know that you have a new book out, feel free to use this time for that. I'll let Pranavi start, I guess.
Yeah, yes. So the information I have to plug is Canva is hiring, especially the observability team. They're really young, and we would love to do a lot more with the team, but we need the engineers for that. So please do apply, and it's an awesome place to work. So that's for me. Thanks.
Ken?
Cool. I guess the only thing really, ThoughtWorks publishes a thing called a radar, which is technology we use and so forth. The new version came out yesterday, so you can check that out. But also, more importantly, if you Google for like build your own radar, you can create one that's for your organization as opposed to ours.
All right, fantastic. I also personally used the ThoughtWorks radar, and I can definitely say that it is it is a very good reference material. And Alex, do you have maybe any, in addition to the book, and we'll make sure to plug it in our description, do you have maybe any speaker engagements that you have, or anything you would like to plug in general?
Yeah, I have a lot coming up. 3 or 4 conferences, several podcasts. The easiest is probably go to alex-hidalgo.com, alex-hidalgo.com. You'll be able to find my schedule there. It's a little bit out to date, but I'll update it tomorrow, I promise. Got a bunch of stuff upcoming. I'm going to be adding a Calendly there as well. I'm going to be starting a weekly office hours where about 4 hours per week I'm going to be open for anyone to book to talk about anything they like to talk about at all. And finally, Noble9, my new company, we entered open beta today. So go to Noble9, that's NOBL9, no E. Although if you go with the E, it'll just redirect you. But go check out noble9.com. We're building a product 100% focused around SLOs and how to use the data that can provide you to make decisions. Our beta went open today. We'd love to work with people, and early adopters, we're going to be taking your feature requests first.
Fantastic. And with that, I wanted to wrap up and say thank you very much to all our panelists. Thank you, Pranavi. Thank you, Ken. Thank you, Alex, for joining us, especially on such late notice. We really appreciate you participating, and we really appreciate your help. I hope you all have a great rest of your day, rest of your evening in case of Alex, and we'll see you next time.
Thank you so much.
All right, thanks so much. Yeah, seriously, I had a blast. Thank you, Ken. Thank you, Pranavi. It was an absolutely awesome conversation. Would be happy to do it again anytime.
Awesome.
Yep. Thanks all.
All right. Now I've